The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. All right, so today we're going to wrap up Chapter 8. We're going to look at Section 8.9, and your homework tonight will include 8.9 along with the chapter review. Section 8.9 is on the topic of variation. So let's go ahead and get started. So we're talking about variation. There are three types of variation we're going to address today. The first type is called direct variation. And in general, it looks like this: y equals kx. K is called the variation constant, or the constant of variation, or the constant of proportionality. I just call it the variation constant since that's the shortest description. And what we'll end up doing is we'll be given some information, a story, if you will, that will tell us what kind of variation we're dealing with. Then we'll be given some information that will allow us to determine what that variation constant K equals. We'll put that number in, and then there'll be a follow-up question that we'll answer. This is very much like y equals mx, thinking in terms of y equals mx plus b, slope-intercept form. But anyway, enough of that for right now. So let's take a look at an example of a problem to do with direct variation. Okay. This problem says free fall. An object in free fall, in other words, it's falling freely, travels a distance s that varies directly to the square of the time t. If an object falls 1,024 feet in 8 seconds, how far will it fall in 10 seconds? Okay. It says an object in free fall travels a distance s. So s equals distance, or we could say distance traveled. Okay, let's see here. That varies directly to the square of time t. So t equals time. All right. So it says the distance s varies directly to the square of time t. Now, I put k, that is the constant of variation, excuse me, I put that in there even though it wasn't mentioned. It will be included in all the different variation formulas, though sometimes it's not even mentioned. We just have to know that it's there. All right, so s equals kt squared. Let me read it once again. An object in free fall travels a distance s that varies directly to the square of time t. So notice that t is squared. It says, if an object falls 1,024 feet in 8 seconds, so 1,024 feet would be s, 8 seconds would be the time. So that gives us this equation. Don't forget that time is squared. So from that, we get 1,024 equals 64k, 8 squared is 64. Dividing both sides by 64 allows me to solve for k. Let's see here. 1,024 divided by 64 is 16. So now I know that k is 16. I'm going to take that and put it back into this general equation to give a specific equation. S equals 16 t squared. Okay, so now I'm going to go back and read the follow-up question. It says, if an object falls 1,024 feet in 8 seconds, which we already dealt with, how far will it fall in 10 seconds? So the distance in 10 seconds. So s equals 16 times 10 squared is 100, which would be 1,600, and that would be, this is what, feet, and this is seconds. terms of units. So the distance would be 1,600 feet. So again, we read the problem, determined that it was direct variation, identified the variables, plugged in the information to find K, the variation constant, used the follow-up question to determine the answer. All right, we're going to look at a second kind of variation, and this is called inverse variation. Oh, one more thing I want to talk about going back to direct variation, okay? With direct variation, in fact, let's go back all the way here. If X increases, Y increases, so they go up together. If X decreases, Y decreases, so they go up together or down together. We say it's direct. If one goes up, the other goes up, one goes down, the other goes down. Why is that important? Well, an inverse variation, which in general looks like this, Y equals K over X, okay, in this scenario, if K increases, if X increases, Y decreases. If X increases, okay, let's start over. If X goes up, Y goes down. If X goes down, Y goes up, okay? So there's that inverse situation going on there. All right, now, again, notice K is present. Let's take a look at an example of inverse variation. It says organ pipes. The frequency of vibration of air in an organ pipe varies inversely to the length of the pipe. If a pipe 2 feet long vibrates 256 times per second, how many times per second will a 6-foot pipe vibrate? Okay, so first of all, let's identify the variables. We've got, it says the frequency of vibration of air in an organ pipe varies inversely to the length of the pipe. Okay, so we've got the frequency. Let's see, frequency of vibration, we're going to call F, and L is going to be the length of the pipe. Okay, it says the frequency of vibration varies inversely to the length of the pipe. So the frequency varies inversely to the length of the pipe. Okay, again, K, the variation constant, is not mentioned, but it's in the formula. So now we're going to go back. It says if a pipe 2 feet long vibrates 256 times per second, so we would have what? 256 equals K divided by 2, because it said 2 feet long, so that's the length of the pipe. 256 times per second, that's the frequency of vibration. It's like ribs, that's vibration there. This will allow us to determine what K is. We'll multiply both sides by 2, and we get K equals, let's see, that's going to be 512. Okay, so now that information is going to go over into our general equation to give us a specific equation for this particular case. So we get F equals 512 divided by L. All right, now the follow-up question. Let's see, where did it go here? So if a pipe 2 feet long vibrates 256 times per second, how many times per second, so that's the frequency, will a 6-foot pipe vibrate? So the frequency will be 512 divided by the length of the pipe, which is 6 feet. Okay, so on my calculator, 512 divided by 6, and I get 85.3 repeating. Recall that 0.3 repeating is equal to 1/3. Don't round off. If you wrote 85.3, that would not be correct. That 0.3 is repeating, so I'm going to write it as a mixed number there. And that, let's see, that would be times. Okay, so that is the frequency of vibration of that 6-foot pipe. All right, any questions about that one? Okay, we're going to look at the final type of variation we're going to study today, and that is joint variation. Joint variation. Are you familiar with a joint checking account? That's where there's more than one person on a checking account. Okay, so joint variation, in general, we have something like this. It'll be y equals k, and then maybe like xz. The point being that there's more than one variable on the right side of the equation. Again, k is always there, though it may not always be mentioned. Okay, so joint variation is kind of like direct variation, except over on the right side, we have more than one variable. All right, let's take a look at an example of that. Let's see here. Okay. Oil storage. It says the number of gallons of oil that can be stored in a cylindrical tank varies jointly as the height of the tank and the square of the radius of its base. All right, so we've got this oil storage tank, okay? And they're going to tell us from the drawing that I'm going to recreate here that the height is 20 feet and the diameter is 15 feet, okay? The number of gallons of oil that can be stored in a cylindrical tank. So we're going to let G equal number of gallons, okay? Actually, tell you what, let's use a capital G there, just because I want to, okay? The number of gallons of oil that can be stored in a cylindrical tank varies jointly as the height of the tank. So H is going to be the height of tank, and the square of the radius of its base. R will be the radius of base, so of the tank's base, okay? The constant of proportionality, or the variation constant, is 23.5. So in this rare case, they tell us, they not only mention K, but they tell us what it is. It says, find the number of gallons that can be stored in a cylindrical tank shown. Okay, so we've identified G for gallons, H for height, R for radius, and K is given as 23.5. Let's go back and read the problem again. The number of gallons of oil that can be stored in a cylindrical tank, so that's G, equals, says varies jointly, so we're going to have K in there, as the height of the tank, so that's H, and the square of the radius of its base. So G equals K H R squared. Now, let's go back and see what we know. We know that K is 23.5 because it was given. We know the height of the tank is 20 feet. Careful. We know the diameter of the tank is 15 feet, but the radius would be half of that. So that's going to be what, 7.5 or 7.5 feet. Okay. So we've got G equals 23.5 times 20 times 7.5, the quantity squared. So 23.5 times 20 times 7.5 squared. Okay. And I'm getting 26,437.5 gallons. Again, I want to mention that you've got to be careful to recall, for instance, here it says the radius is squared. Make sure as you go on in the problem, you keep the radius being squared. That's one of the most common mistakes when there's a square or a cube in a formula. Students will forget to square it or cube it, so be careful with that. All right, so here we have an example again of joint variation. So I want to go back through these again. We had direct variation. Notice K is there. It's always on the right side in the numerator. y equals kx, direct variation. They go up together, they go down together. Joint variation, y equals k divided by x. So you've got that variable on the right side in the denominator. As one goes up, the other goes down. As one goes down, the other goes up. Again, k is present in the numerator. And finally, joint variation, k again is present in the numerator, but you've got more than one variable on the right side. So you've got things like y equals kx, y equals k over x, y equals kx z. And of course, the variables x, y, and z, those are just starting points. They'll give you specific things in the problem. I really encourage you to label your variables what they are ahead of time so that you don't get confused as to what it is you're finding. All right, now I want to look at some examples where we're just going to translate a sentence into a formula form and then a formula into sentences. And if that doesn't make any sense, hang on, you'll see as we do it. For instance, this says, express each verbal model in symbols. It says A varies directly as the square of P. So A equals KP squared. Again, K is always present, though not always mentioned. Any questions on that example? All right, let's take a look at another one. Z varies inversely as the cube of T. So Z equals K divided by T cubed. Again, inversely, and T is cubed. Let's see here. There's another one. C varies, let's see, hang on here. Jointly as X, Y, and Z. So C equals K, X, Y, Z. This one has a combination of things. It says P varies directly. So P varies directly as the square of A and inversely as the cube of J. So we've got two things going on. P equals KA squared over J cubed. It's varying directly as A squared, or the square of A, and inversely as the cube of J. So we can have direct variation and inverse variation going on at the same time. All right, let's go the other direction. Let's take this situation. A equals KR cubed. So we would say, writing it in words, A varies directly as the cube of R. And let's see here. This one, D equals K divided by W to the fourth power. We would say D varies inversely as the fourth power of W. And let's look at one more of those. Let's see here. R equals KL divided by D squared. We would say R varies directly as L, and in writing was never my forte, or printing, and inversely as, let's see here, where did we go here? Well, that's supposed to be a D, as D squared. All right, so you've got three kinds of variation: direct, inverse, and joint variation. So you need to have those formulas memorized for your upcoming test, the general forms. So again, here's direct, inverse, and joint variation. So tonight's homework is to wrap up this chapter, section 8.9, also to do the chapter review exercises. Tomorrow during class, we'll review for the test coming up on Thursday. So again, just a reminder, on Thursday, there won't be an actual class meeting. You'll just be taking your test. And again, you can take your test early. You can do any of the assignments early. You just can't do them after the deadline. I'll be back at 1:15 today with an office hour, should you have any questions. Anyway, I'll go ahead and stop the recording.